Okay, so since the question moment it cropped, I don't know why. So I'm going to return to it, explaining C and D. A and B are already explained in part 1. So I'm going to just explain C and D. So again, this is our system. We have a motorcycle and a rider, and the motorcycle, it has a weight of 1100 Newton. The rider, it has a weight of 780 Newton. You should, as always, read the question very carefully, because it can tell you a lot of things about how to think about the question, how to solve the question. So they said by taking the moments about B. So this is a very important thing in the question. They told you what formula you should use or what way you should use. You should take in consideration the moments, and as because we have more than one moment acting about point B, so B is here the pivot. Calculate the vertical force. So there must be a vertical force in our system in order to reach the equilibrium condition, the other equilibrium condition. So this vertical force is acting on the tire, front side of the tire A. So we are going to use the formula of moments, knowing that yes, moments in a clockwise acting in a clockwise way should be equal to all the moments acting in the anti-clockwise way about our pivot B. You should specify all the moments in which way the forces are acting in an anti-clockwise or in a clockwise way before starting solving the question, and pay attention to get all the forces. And again, we don't add forces, we add moments. So here we have only one clockwise moment, which is Fa, acting about the pivot, acting away from pivot B with a distance, perpendicular distance of 1.3. So 1.3 meter. Yes, 1.3. This should be equal to what? This should be equal to two moments acting in an anti-clockwise way. The 780 multiplied by 0.35, and we have the 1100 multiplied by 0.6. So by this way, using this way, we are using the first condition of equilibrium. So you will do just normal math calculation, where you will say Fa times 1.3 should be equal to 933. This is when you multiply this quantity and you add to it this quantity, you'll get 933. Then you will cross 1.3 and divide by 1.3, because you have here a multiplication, it will become a division. Okay, so 1.3, and you will end up with Fa equals to 718 Newton. So this is our answer. This is the answer. As for question D, now they said they also want us to calculate something. They want us to calculate the vertical force. So there is another vertical force in our system that the road exerts on the rear tire at B. So at point B right here, we have like a kind of force that is also vertical acting about B, that we don't know the value of this force. It's called Fb. So you may think of doing the same way, like using the moment condition. But this is not possible here because this force is acting right at the pivot, so it will have no moment. And this is a very important thing to notice. You should always check whether you have a moment acting or not. So this has no moment. This is why we will use the other condition of equilibrium, which is all the sum of the upward forces will be equal to the sum of downward forces. We have two upward forces, Fa and Fb. So Fa plus Fb, they should be equal to 780 plus 1100 Newton. So you will add these two together, they will be equal to 1880 Newton. And substituting Fa with the value that is already found in question C, 718 plus Fb. Now what you are going to do is you are going to cross this one, and since it's positive, displacing it will make it negative. So minus 718, and this will give you the value of Fb, which is equal to 1162 Newton. So this is the answer of question C. Okay, great. Hope this was helpful, and thank you, Hassan, for notifying me, and good luck and study well, and that's it.